Hello everyone, welcome to my programming club. Today we will be solving another daily Leetcode challenge, and the challenge name is minimum cost to connect all points. So you are given an array of points representing integer coordinates of some points on a 2D plane, where coordinates of a point will be in form x comma y, where x will be the x coordinate and y will be the y coordinate of the point in a 2D plane. So the cost of connecting two points will be the Manhattan distance between those 2 points. The Manhattan distance will be absolute difference of their x coordinates plus absolute difference of their y coordinates. So where value denotes the absolute value of this two straight lines denotes the absolute value of the well. So return the minimum cost to make all the points connected. All points are connected if there is exactly one simple path between 2 points. So what the problem essentially is asking us to do is we have to find the minimum spanning tree of this graph, MST, minimum spanning tree. Those of you who are not familiar with what is minimum spanning tree, I will be providing a link describing minimum spanning tree, link of an article describing minimum spanning tree, and we will be solving it using Prim's algorithm. Basically, it is an algorithm to generate minimum spanning tree. And those of you who are also new to this algorithm, I will be also providing a link for article describing this algorithm. Now let's have a look at the approach. Basically, I will be explaining the algorithm here in a video itself also. If you still want to explore further, you can use this link and read that article or blog. What we will be doing is you will be given an array of points. This will be the x and y coordinates of each point. So what you will do is you will mark the indices of this particular given array. So it's also mentioned that let's have a look at the constraint first. So the points of this length of this particular array points will be of order 10 raised to power 3, and your coordinates will be lying between 10 raised to power minus 6 to 10 raised to power 6. So all the pairs will be distinct. So what you will do is you will consider your indices as your nodes. Consider your indices of the points array, your nodes of MST. Initially, you can start from any of these nodes. Let's say I decided to start from the very end. Let's say I decide to start from this node. So I will mark this node as the current source node. Basically, initially your MST will be empty. So this will be the very first node you will be entering in the MST. Now, for all of the rest nodes, you will check what is the distance of these nodes. This will be your current MST. what is the cost of these nodes so that these can be added to this current MST? It will be basically nothing but the distance between this current node 3 and all these nodes individually. So let's say uh, cost of connecting 3 and 2 is, let's say, x, and cost of connecting uh, 3 and let's say 0 is let's say y. So this will be the distance of Manhattan distance between 3 and 2, and similarly this y will be the Manhattan distance between 3 and 0. The point at the third index and the point at the 0th index, the point at the second index and the point at the third index of the points array. So I hope you are able to understand what the cost is. So you will get the minimum of these nodes, remaining nodes. You will get the minimum cost such that that such that the node that will be added is not present in MST. So any of these nodes is not currently present in minimum spanning tree. So among these nodes, whichever node will be having minimum cost to be added to the MST will be considered to be added next. And once let's say a new node is added, let's say initially it was 3, now let's say 2 was having the minimum cost to be added to the MST, then MST will be looking like this. Now you will be having options of 0 and 1 node, and since you have added a new node to the MST, uh, each time a new node is added to MST, you will update the cost of adding each remaining node individually to MST. So cost of 0 will be updated, cost of 1 will be updated. It will be minimum of its previous cost and the cost from this current node that is being that have been added. So, and you will keep repeating this until the size of MST reaches to size of points array. So this will be your approach. Now let's have a look at the implementation. It will be more clear to you in the implementation part. So this is the approach. First of all, what you will do is this MST will be used. This set will be used to keep track of nodes currently present in MST. So and you will pick any one of the. Also, it is to be noted that the indices points array or say vector used as node numbers to be added to the MST that will be formed. So you will pick any of the nodes initially. Since MST will be empty, you can pick any of the nodes as your first node to be added in the MST. I have picked size -1, the last node, as the node to be added initially in the MST, and then you will start building your MST further. So initially, in each iteration, current source value of node will be set to -1, and the nodes having minimum, and the node which is having minimum cost to be added to the MST will be considered for addition. Then you will add that node to the MST, and also add its cost to the overall cost. Then what you will do is you will update the cost of joining the MST for each of the node which are not present in, for each node which are not present in MST as of now. So here also you will consider only those nodes which are not present in MST as of now. So then you will return your minimum cost. This is a function which is to calculate the Manhattan distance. It is pretty much same as this formula that is given here. This formula, absolute difference of x coordinates plus absolute difference of y coordinates between 2 points. So let's try to submit it once. As you can see, it's getting accepted. So the code will be available in C++ and Java both. If you are still having any doubts, please feel free to ask them in the comment section. I will be more than happy to answer them. Thank you for watching. Thanks.